Hello everyone, myself Dipanshu Namdev and I study in SGS ITS College, Indore, Madhya Pradesh. In this video, we are going to study BCNF, which is a normal form used in database designing. So, first of all, let's just recall what is normalization. Normalization is a design technique in database design that reduces redundancy and anomalies in our database. Okay, so in this we split our table into multiple tables, a single table, based on the functional dependencies that reduces the redundancy that was being caused in a single table. And during splitting the table, we define the relationship among those tables as well. So why normalize? Right, that eliminates, first point, eliminate data redundancy, avoid update, insert and delete anomalies, ensure data integrity and improve query performance. The query performance increases in this, but the thing is that the number of tables increases as well, so the query becomes more complex as the normalization increases. So we have to maintain the balance between both of these things. So let's just recall the normal form before the BCNF, that is 1NF, in which we eliminate repeating groups like multi-valued attributes and composite attributes. We create separate tables for them during conversion from ER model to schema. Now the second NF form, in which we remove the partial dependencies. So let's just recall what a PD is. Partial dependency is such that suppose we have AB, which is a key in our relation, and one of the proper subset key, that is a prime attribute of a candidate key, which defines a non-prime attribute, let's just say C. This kind of functional dependency is partial dependency. So if it exists, then our relation is not in 2NF form, and in 3NF form there is, if there is transitive dependency in our schema, then it's not in 3NF form. What's a transitive dependency? In which a non-prime attribute defines another non-prime attribute, then it's a transitive dependency, and the schema is not in 3NF form. Now coming to the main topic of the video, that is BCNF, in this every determinant must be a super key. So let me show you what does this mean. Suppose there are functional dependency of form alpha is to beta in our relation. So for every functional dependency, the alpha must be a key. That's it. It's the criteria for the relation to be in BCNF. So BCNF full form is Boyce Codd normal form, and a relation is in BCNF for every functional dependency x gives y, x is a super key, right? So why BCNF is needed? Obviously to come over the anomalies of 3NF, and BCNF ensures all dependencies originate from super keys. So the chances of occurring on anomalies comes to the very least, come to the minimum. And at the enterprise level as well, the companies prefer 3NF and BCNF in their databases. So these are two both widely used relation normal forms. So let's just take an example of a relation R, in which we have student ID, course and instructor, in which student ID derives course and course derived instructor, and in this student ID is our candidate key. Student ID is a candidate key because the closure of student ID gives both course and instructor. So coming to this functional dependencies back, course derives instructor. It's a transitive dependency, so this relation is not in 3NF form. We can say that it's in 2NF form because we can't see any of the partial dependency in it, right? Now let's just decompose this example relation into BCNF form. So what we'll do is just split the table around both of these functional dependencies, and this in this FD's LHS both will become the key of the new originating two tables. As you can see, we decompose the given R into R1 and R2, and in R1 course and instructor, and in R2 there are student ID and course, and these are both the functional dependencies which we had in the original R. Now since alpha derives beta for alpha to be a super key for the relation to be in BCNF, here course and student ID both are the candidate keys of their respective tables, so we can say both relations are now BCNF form. So what are the advantages of BCNF? The same thing comes around back again, why we needed BCNF. Stronger normalization, redundancies are reduced, eliminates all anomalies which were in 3NF, leads to better database design, right? And this is just a summary overview which all we have discussed in the video yet. Thank you for watching the whole lecture, and if you have any feedback or want to suggest something around the content of the video, please do comment in the video. Thank you.